This week we're going to be talking about heat transfer and global winds. You might be familiar with some of this stuff because I know you guys studied the structure of the Earth last year, so you might be familiar with things like convection currents and some of the other things that we go over. Okay, here we go. Objective 14, I can describe the three different types of energy transfer. The first one is conduction. You can see in the picture, conduction is the direct transfer of thermal energy. Thermal, remember, meaning heat. Thermal energy from one substance to another that is touching. So over here you can see that this rod is getting hot, and so this guy's glove over here is going to get hot because those two things are touching. Okay, so conduction is two things that are touching, like a pot touching the stove. That's conduction. Okay, radiation is the direct transfer of thermal energy by electromagnetic waves. So we talk about radiation all the time, talking about radiation coming from the sun. Okay, that's how you feel the warmth of the sun. That's through radiation. And the last thing that we have is convection, which we're going to be talking about a lot. It's the transfer of thermal energy by the movement of a fluid. So in the case that you're looking at right here, the fluid is the air. Okay, so we have convection currents happening in our beneath our Earth's crust in the magma, because as the magma warms up, it's going to come to the surface of the crust, and when it gets up there, it's going to start cooling down and it starts sinking again. So you might have talked about that last year in 6th grade. We have convection currents in the ocean, so the water is warmed by the sun at the top, and then so it stays there, and then as it cools down, it starts to sink, and then the warm water rises, cold water sinks. Okay, same with the air. So your warm air is going to rise, your cold air is going to sink. So warm air is going to be associated more with low pressure because it's less dense, and then cold air is going to be more associated with a high pressure system because it's more dense. Remember, cold air is more dense than warm air, and we talked about that last week. Okay, go ahead and pause this video right now. This is Objective 14. Moving on to Objective 15, I can describe convection currents. So that's what we were just talking about. They occur within the earth, the ocean, and in the air. Warm air or water rises because it's less dense. Cold air or water sink because it's more dense. And convection currents cause wind. This is Objective 15. Go ahead and pause. Objective 16, I can define wind, describe what causes wind, and explain the different global wind belts. Well, we just talked about what causes wind, and that is convection currents. Okay, we have that warm air moving up, cold air moving down. Because we have that movement of air, that's actually what causes wind. So what is wind? It's the horizontal movement of air from an area of high pressure to an area of low pressure. Winds are caused by the unequal heating of Earth's surfaces, creating convection currents which cause differences in pressure. Again, we're going to get more into high pressure, low pressure systems the end of this week, actually the end of next week. So we'll be talking about those things more, especially as we get into forecasting and what those pressure systems bring with them. And in North America, more specific to us, our winds move our weather from west to east by the prevailing westerlies. And winds are named after where they come from. So they blow west to east, and they're called the westerlies because they come from the west. Okay, again, winds are named for where the wind is coming from. This is Objective 16. Get it written down. Go ahead and pause. All right, moving right along. You can see that this is explaining all the different global wind patterns that we have. So we talked about, again, the westerlies, and this is where we are in North America right here. Okay, so they're called the westerlies, again, because they blow from east to west. Okay, and the easterlies, you got it, you guessed it, they blow from east to west. Winds are named for where they are blowing from. Okay, your northeast trade winds and southeast trade winds are occurring around the equator. Right here is the equator. Here's your northeast trade winds, your southeast trade winds. And then at your horse, you have your horse latitudes where your oh, all my things didn't pop in, guys, so give me 1 second. Let me get these all in. There we go. Okay, so again, your easterlies blow from the east to the west. And I wasn't in drawing mode. Technical difficulties today. Okay, here we go. Your easterlies blow from east to west. Your westerlies blow from west to east. Okay? So look at your prevailing westerlies. They blow away from your horse latitudes. Your horse latitudes, which are right here and also down here in the southern hemisphere, they're areas of calm falling air, which means the air is sinking. So because it's sinking, we're going to assume that that air is colder air. It's falling air. It's cold. Okay, remember that cold air sinks, warm air rises. Okay, look at this. Here's the doldrums. Look where the doldrums are. They're right at the equator. They're areas of rising air. The air is rising because we know right here at our equator is where we are getting the most direct sunlight all year long. So they're calm areas of rising air because that air is being heated up. And as it and we look at the horse latitudes, remember that is falling air because it is further away from the equator. They're not getting as much direct sunlight. Okay? Your trade winds blow from your horse latitudes toward the equator. Okay, so in the south, they are blowing to, again, towards the equator in the south and in the north. And then your polar easterlies, again, when we talked about those, they blow cold air away from the pole. They're called easterlies because they blow from the east to the west. Okay, I'm going to get rid of the drawing on here. And you need to copy all of this down. Make sure that you are also getting all these little areas of extra information on the right-hand side where it's talking about the prevailing westerlies, the horse latitudes, the doldrums, trade winds. Draw this. Draw the arrows to show how your winds are moving, because these are called your global wind belts. Go ahead and pause. Okay, moving right along to objective 17, I can describe the Coriolis effect. The Coriolis effect is the change that Earth's rotation causes in the motion of the objects and explains how winds curve. Okay, as air moves from high to low pressure in the northern hemisphere, it's deflected to the right. So northern hemisphere, your winds are deflected to the right. And in the southern hemisphere, air moving from high to low is deflected to the left. So southern hemisphere, your winds are deflected to the left, while in the northern hemisphere, they're deflected to the right. So if you look at this diagram down here, your straight arrow indicates the way in which the direction of the air should move. Okay? But because of the Coriolis effect, which means our Earth is turning, okay, that means that our winds are actually going to deflect. This is the intended path. This is the deflected path. Okay, we're going to the right depending on which way the winds are intending to go. Okay, so in the northern hemisphere, again, they're going to deflect to the right, and in the southern hemisphere, they're going to deflect to the left. And just a little interesting tidbit, the Coriolis effect also causes the water in our toilets to spin a certain way. So because if you look here, in North Carolina, you flush the toilet here, the water is going to spin clockwise, okay, towards the right. But if you go down into the southern hemisphere and you flush a toilet in the southern hemisphere, it's actually going to spin counterclockwise, okay? Just an interesting little tidbit. Go ahead and pause this. This is objective 17. Okay, I'm going to bring you guys to a quick little brain pop. This is on winds.
Dear Tim and Moby, where does wind come from? From hope. Well, that's one way to move air, and that's just what wind is, moving air. But there's no giant propeller pushing wind around the earth. Believe it or not, the wind is caused by the sun. If you've seen our thing on seasons, you know that the tilt of the earth causes some places to be hot or cold at different times of the year, and other places to be either hot or cold all year round. The uneven heating of the Earth's atmosphere is what gets air moving. The sun heats up the Earth's surface, warming the nearby atmosphere. Warm air weighs less than cool air, so it rises. Rising warm air leaves an area of low pressure, and cooler air moves in to fill it. Meanwhile, the warm air, away from the warm surface of the Earth, cools off and sinks back down. What you end up with is a whole lot of moving air, and that's what we here at BrainPop like to call wind. There are different types of wind that blow in different patterns. Prevailing winds blow all the time over a particular part of the world. They're constant because the equator always gets more direct sunlight than the poles, and that creates a pressure difference. Warm air moves away from the equator towards the poles, where it cools off. Their direction is affected by the Earth's rotation. Winds in the northern hemisphere are deflected to the right, and they turn to the left in the southern hemisphere. Jet streams are strong winds that blow about 10 kilometers above ground. They blow in circles with one jet stream over each hemisphere, and they blow fast, up to 200 kilometers per hour. Jet streams can move big chunks of air and really affect weather. Trade winds are mild, constant winds that blow towards the equator from the northeast or southeast. Where the trade winds meet, there's a calm area called the doldrums, where there's hardly any wind at all. Local winds are particular to certain countries or areas. Geographic features like mountain ranges or bodies of water can drastically affect wind conditions and create localized winds like the Santa Ana winds in the North American Rockies and the Föhn in the European Alps. Wind power can be harnessed to make electricity, which you can learn about in our Energy Sources movie. What are you doing? What do you mean you're trying to break wind? You can't break wind. It's made of air. What?
Okay, guys, check that out. It's 12 minutes, 36 seconds right now. I'm still under 15 minutes, even with showing you guys a movie. All right, I know I was heavy in notes this week, but that is it for this week. I will see you in class. Make sure you bring me any questions you might have.